Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 1 Sets, Relations and Functions. Topic Sets, Relations and Functions. Exercise Miscellaneous Examples on Chapter 1. Question 1. Decide among the following sets which sets are subsets of one and another. Makhagi setsing asidagi karamba setki subsetsing putu'u. A. X such that X belongs to R and X satisfying this quadratic equation. B consists of 2, 4, 6. C consists of 2, 4, 6, and so on. D consists of 6 only. Here A is this, B, C, D are given. Now solving this quadratic equation, we get X equal to 2 and 6. Therefore A consists of 2, 6. Now we have two forces A, B, C, D. Let us see. We have A consists of 2, 6, which is also in the set B. Therefore A is subset of B. And the elements of A, that is 2, 6, which are also the elements of the set C. Therefore A is subset of C. Next, B is subset of C. That is element in B is also an element of C. Therefore, B is subset of C. D is a subset of A. D is subset of B. D is subset of C. Question 2. In each of the following, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. Roman number 1. If X belongs to A and A is an element of B, A belongs to B, then X belongs to B. The statement is true or false? The statement is false. Let X consists of 1, 2, B consists of 1 and 1, 2 set and set consisting 3. Now X equal to T from A and the set A is also an element of set B as by given. That is A is an element of B. However, 2 does not contain in this 2 is not an element of the set B. Roman number 2. A is subset of B. B is an element of C. Then A is an element of C, which is also false. Let us take A consists of set 2, B consists of 0, 2, C consists of G1, set consisting 0, 2 as an element and 3. Thus A is a subset of B and B is an element of C, but A is not an element of set C. Roman number 3. A is subset of B, B is subset of C, then A is subset of C. The statement is true. Let us prove. Let A is a subset of B and B is subset of C. These two are given. Let X belongs to A implies X belongs to B because A is subset of B. Again, B is subset of C, therefore X belongs to C. Thus, X belongs to A implies X belongs to C. This shows that A is subset of C. Question number 2, remaining parts. In each of the following, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. A is not subset of B and B is not subset of C, then A is not subset of C. False. Let A consist of 1, 2, B consists of 0, 6, I. Now A is not subset of B. And next, C consists of 0, 1, 2, 6, 8. B is not subset of C. Accordingly, A is not subset of B, B is not subset of C. However, A is subset of C. A is 1 belongs to A implies 1 belongs to C. 2 belongs to A implies 2 belongs to C. Therefore, A is subset of C. For Roman number 5, if X belongs to A and A is not subset of B, then X belongs to B. If X belongs to A and X is not subset of B, then X belongs to B. The statement is false. Let A consist of 3, 5, 7, B consists of 3, 4, 6. Now 5 belongs to A, 5 belongs to A, and A is not subset of B. The first two conditions are fulfilled. But however, 5 does not contain in B. 5 से B दी यावदे. Hence, proof. For Roman number 6, if A is subset of B and X does not contain in B, then X does not contain in A. The statement is true. Let A is a subset of B and X does not contain in B. These two are given. To show X does not contain in A, if possible, suppose X belongs to A. X asi A da yawba element amani haina lawsilasi. Then X belongs to B as X A is subset of B. A is subset B orabanina A da yawba X to B da yawbam to A. But B ase B da yawde haina piramle. X to B da yawde haina piramle, which is a contradiction as X does not contain in B. Therefore, X does not contain in A. Hence proof. The question number 3. Let A, B, and C be the sets such that A union B is equal to A union C and A intersection B is equal to A intersection C. These two conditions are given so that B equal to C. Let us prove. We have to show that B is equal to C. First, we have to prove B is subset of C. Let X belongs to B implies X belongs to A union B, since B is subset of A union B. But A union B is already given as A equal to C, implies X belongs to A union C. This shows that X belongs to A or X belongs to C. We have two conditions. If X belongs to B and X belongs to A, then X belongs to A intersection B. Implies X belongs to A intersection C as A intersection B equal to A intersection C. This shows that X belongs to C. Implies X belongs to B, implies X belongs to C. This shows that B is subset of C, which is equation 1. Similarly, we can show that X is subset of B. C is subset of B. We can prove. Combining these two, combining 1 and 2, we get B equal to C. Two sets are equal if is subset of other. Hence, we get B equal to C. Question number 4. Show that the following 4 conditions are equivalent. A is subset of B, A is subset of B, A minus B is pi, A union B is B, A intersection B is A. Let us draw diagram. This is A, this is set B. Now A is subset of B for pass point. And Roman number 2, A minus B, there is no element in A which does not contain in B. That is given by 2. Roman number 3, A union B is automatically B, Roman number 3. And Roman number 5, A intersection B, intersection of this set A and set B, automatically that will be this set A. First, we have to show that Roman number 1 in if and only if Roman number 2. Roman number 1 chumadi, Roman number 2 statement chumi, Roman number 2 statement chumabadi, Roman number 1 chumi haibasi proof toksi. Ahanbada Roman number 1 chumi haina lauraga A subset of B haibasi it is given, it is supposed. Masi piram mi haina lauraga A minus B si pi tagani haibasi proof toksi. A is subset of B, it is given. We have to show that A the minus B is pi. Let us prove. Let A is subset of B, it is given. To show A minus B is pi, if possible, suppose A minus B does not equal to phi. A minus B pi tabasi proof togadabani A minus B se pi tadre haina lawsilasi. Labadi, masi A minus B is a pi natre labadi, A minus B da yamdrabada element amalegani haibani. This means that there exists X belongs to A, X does not contain in B, which is not possible as A is subset of B. A minus B si phi tadre haina oithoklabadi laushile masige arthadi A da yauba X tai B da yaudaba element X neba. Masi oithokte maramdi A asi B gi subset oibanina. A na B gi subset oirabadi A da yauraga B da yaudaba element sungai leraroi. Adudi therefore A minus B C automatically phi adum tagani. This gives what? Thus A is subset of B habasi suppose given oiraga A minus B is phi tai ulle. Sina kari hare. Therefore Roman number 1 implies Roman number 2. Roman number 1 ki condition sumi haina lauraga Roman number 2 ki condition si sumi haina prove tori. Conversely, next day. Conversely, let Roman number 2 sumi haina lauraga Roman number 1 statement si prove to gudribani. Suppose conversely let A minus B is phi it is given to show A is subset of B. A si B is subset ni haigadrin. Let X belongs to A. X da yauba A da yauba X haiba makak aikhoin A da yauba X haiba element makak laukhatle. Clearly X belongs to B. X at B the soidani yaurani. A the yauba X to B the soidani yaurani. Because if X does not contain in B, X to B the yauramdra B the yaudrabadi, then A minus B z does not equal to phi. X have a say A the yawe haina laure X to B the soidani yaurani. Because if X does not contain in B, X to B the yaudrabadi, then A minus B adopt phi taro. B the yauba A the yauba X to B the yaugani maramdi X to B the yaudrabadi X to B the yaudrabadi A minus B do phi gamanaroi habadi at least element amalaigani. Therefore A minus B phi implies A is subset of B. A minus B phi have a C piram labadi A is a subset of B soidana oigani. Masina Roman number 2 chumabadi Roman number 1 chumi. The condition ani say Roman number 2 implies Roman number 1, Roman number 1 implies Roman number 2, condition ani se punjalabade. Hence what Roman number 1 if and only if Roman number 2. Next, secondly, we have to show that Roman number 1 implies Roman number 3. So that Roman number 1 if and only if Roman number 3. Let Roman number 1 that is A subset of B, it is given to show that A union B is automatically B. We have to show that these two sets are equal. Clearly B is subset of set anise amana amagi subset ni haina prove tausi. B asidi A union B gi subset soiden oigani haibasidi yam laina khangle. Set anigi union aduna makoi gi components sing adudagi soiden superset oigani. Next, A union B C A is sub B is subset ni haigadurimi. Let X belongs to A union B. A union B diyaw X haibama loksele. Then that gives X is either in A or X is in B. If X is in A, if X is A diyawram labadi, then X belongs to B. X belongs to B diyawgani. A diyaw khudingmak B diyawgani maramdi A asi B is subset oibanina. Sina karita A union B is subset of B. A union B diyaw kiba X to hujik B diyawhan bangamle. Condition asida yaw X belongs to A union B ado X to B diyawhan bangamlabadi A union B is subset of B. Already B is subset of A union B. Hujik na A union B is B is subset ore. Ani se punjalabadi if condition namaga walori if X belongs to B, then X belongs to B oirabadi, then A union B is subset of B. Maramdi X haibasi B the yaurabadi B the yaurabadi A X haibasi A union B the hana yaukrabani. Maramasina A union B the yaukibi X to B the yaurabadi A union B is B is subset ni. Condition ani se punjalabadi A union B is subset of condition ani se karita A union B is B is subset ni. Masina A B subset of A union B, A union B subset of B come angang mana iriba ani si punjalabadi A union B is equal to B. This shows that Roman number 1 implies Roman number 3. Mathangdi Roman number 3 na Roman number 1 chumi utkadarani. Conversely, let A union B is B. A union B asina B ga manai haina piramle adudi A asi B ge subset ne haigadurmi. A asi B ge subset ne haigarabadi A diyawa arbitrary element number locality. Let X belongs to A, then X belongs to A union B since A is subset of A union B. A diyawa X ado A union B diyawre. A union B diyawrabadi X dot B diyawre. X dot A union B diyawrabadi X dot B diyawgani maramdi A union B haibase B ga manakre. A union B se B ga manakre. A union B se B ne sindokrabadi X area of X dot B diawre. The area of X dot B diawrabadi A is subset of B. Sinakarita A Roman number 3 implies Roman number 1. 1 implies 3, 3 implies 1. Ani se punjillabadi. Hence Roman number 1 if and only if Roman number 3. Question number 4 continue. Lastly, we have to show that Roman number 1 if and only if Roman number 4. Let A is subset of B, Roman number 1. Roman number 1 na Roman number 4 to utsi. A is subset of B. It is given. Clearly A intersection B is subset of A. Masidi masana tajarabani. Let X belongs to A. Aba maloksile X to B diyaurani maram di A si B ge subset ni haina piram labani na. Therefore X belongs to A intersection B. X to A diyaw ki bani B diyaw. A diyaw ki bani B diyaw utpangam labadi X belongs to animak diyawre. Therefore A is subset of A intersection B. Hence A equal to A intersection B is subset of A. A is subset of A intersection B. Hence A equal to A intersection B. Conversely, suppose A intersection B is A. It is given. Let X belongs to A. X belongs to A intersection B. A adobo A intersection B ne replace to kibani X to A da and X belongs to B. Animak yaurani. Implies X belongs to B ni koina pame bedi X belongs to B kaktang anis dagi lokhatle. X belongs to A implies X belongs to B. This gives A is subset of B. Hence, Roman number 1 if and only if Roman number 4. Question number 4 proof to below. Question number 5. So that if A is subset of B, then C minus B is subset of C minus A. Here A is subset of B. To show C minus B is subset of C minus A. Subset ni proof to C. Let X belongs to C minus B. This shows that X belongs to C, but X does not contain in B. X belongs to C, but X B the yaudra A as C B is subset or banina as over to the yaudra body masad the yaur X does not contain in A. This shows that X contain in C minus A. C minus B is subset of C minus A. Hence proof. Question number 6. Assume that power set of A is equal to power set of B so that A equal to B. Power set of A ga power set of B ga manarabadi A ga B ga managani have a proof to. Here P of A is equal to P of B. To show A equal to B, let X belongs to A. Let X belongs to A. A belongs to in power set of A. X have a C A element amani. A have a C P of A element amani. P of A as P of B gamana krabanina A as a hosic. Therefore, X belongs to C for some C belongs to P of B. X belongs to C as a for some C belongs to P of B. P of B element as C haiba amad X yauram lani. Now C is subset of B. Now C as a subset B on C have power set of B the yawa element have CD C have CD B is subset name. Therefore X belongs to B. X to C the yaw kibani X to B the soy the yaurani. Now X A the yawa X B the yaw utpangamle. A is subset of B. Similarly, we can show that B is subset of A. A is subset of B, B is subset of A. Combining these two, we get A equal to B. Hence proof. Question number 7. Is it true that for any sets A and B, P of A, power set of A, union power set of B equal to power set of A union B? Chumgadra have statement. Justify your answer. Chumoy. False. Suppose A consists of 1, 2, B consists of 2, 3. Then P of A consists of these 4 elements. P of B consists of these 4 elements. Their union gives this. Makoi union sitarani. But A union B D 1, 2, 3, 2 kamalotokrani. P of A the yaugad P of A union B the yaugad the siga outcome singshini. Uzimataki set siga makaki set and siga element masing anisi manadre. Thus P of A union P of B does not equal to P of A union B. Manaroy. Hence proof. Number 8. So that for any sets A and B, A is equal to A intersection B union A minus B, and A union of B minus A is equal to A union B. We have to prove these two. First part, let X belongs to A. Then X belongs to A then X is either in A minus B, or X is in A intersection B. Anis the Yabama, not the Yabama destroyed. Implies X belongs to A intersection B, X belongs to A intersection B union A minus B. Therefore, A is subset of A intersection B union A minus B, Roman number 1. Again, let X belongs to A intersection B union A minus B. This gives X is in A intersection B or X is in A minus B. It implies X belongs to A. A case animakta X to A the yaurani, X to A the yaurani. The X belongs to A. This shows that A intersection B union A minus B is subset of A. Combining 1 and 2, we get set anisi aman amagi subset orabanina A equal to A intersection B union A minus B. Jumlani. Second part. Let X belongs to A union B, then X belongs to A or X belongs to A intersection B or X belongs to B minus A. X to A union B the yauraba the X to A the yauba ama, or X to A intersection B the yauba ama, or X to B difference A the yauba ma portion ahum sigi manung the yaurani. Akon bagi anisi combined theory. Imply if and only if X belongs to A or X belongs to A intersection B from the grouping sakare. See a left out tahore. This shows if and only if X belongs to A. X belongs to A or X belongs to A intersection B hierarchy. X belongs to A. Combined theory X belongs to A tari. Or X belongs to B minus A. If and only if X belongs to A union of B minus A. Therefore, A union of B minus A is equal to A union B. Hence proof. Question number 9. Using properties of set so that Roman number 1, A union of A intersection B is A. Roman number 2, A intersection of A union B is A. Roman number 1 proof toxi. We know that A is subset of A. Masana masagi subset ni hybrid koi kangle. Equation 1. And A intersection B is subset of A. Roman number 2. A ga any subset ka intersection taurabadi madu A ga subset oigani hybrid koi hana su kangle. Equation 2. Therefore, 1 and 2 is combined to the A union of A intersection B is subset of A intersection A union A. That is A. Equation 3. Also, A is subset of A union of A intersection B. Equation 4. Is combined to by 3 and 4. Aman amagi subset over the A union of A intersection B is automatically A. Hence proof Roman number 1. For Roman number 2, to show A intersection of A union B is A. A intersection of A union B is A intersection A union A intersection B. Combined to the anisi amo A intersection A na replace mouse do kran na sumsip pangai. Masidi kaya gamana kre A union of A intersection B already A ga mana kare from equation 1. Hence, Roman number 2. Question number 10. So that A intersection B is equal to A intersection C need not imply B equal to C. A intersection B equal to A intersection C na A intersection C na B equal to C oigani haiba leiti. Ani se manarabasu B ga C ga manadaba yai. Let A consist of 1, 2, 3, B consists of 2, 3, and C consists of 2, 3, 4. Their intersections are A intersection B is 2, 3, and A intersection is also 2, 3. But B is C. Thus A intersection B equal to A intersection C, but B does not equal to C. B is C. Hence proof. Question number 11. Let A and B sets if A intersection X equal to B intersection X equal to pi and A union X equal to B union X for some set X so that A equal to B. Hence, A equal to A intersection of A union X, B equal to B intersection of B union X, and use distributive law. We have A equal to A intersection A union X. Apply A union X is replaced by its equivalent value B union X. Applying distributive law, we get A intersection B union A intersection X. A intersection B remains unchanged. A intersection X is equal to pi. Any set union with pi is any set A intersection B. Also, B can be written as B intersection of B union X. B union X can be replaced by A union X. Apply distributive law B intersection A union B intersection X. B intersection X is already equal to pi. Their union is A intersection B. These two rights are equal, therefore two lefts are equal. Therefore A equal to B. Question number 12. Find sets A, B, and C such that A intersection B, B intersection C, and A intersection C are non-empty sets, and A intersection B intersection C equal to 5. Pairwise non-empty set sing oiba adu makoi ahum intersection na 5 taba set ahum du putu u haiban. Let A consists of 1, 2, 3, B consists of 2, 3, 4, C consists of 1, 4. Then A intersection B is 2, 3, B intersection C is 4 only. A intersection C is also 1 only. Also, A intersection B intersection C is set ahum's intersection torade pi set ahum's makti yawa element laite. Hence proof. Question number 13. In a survey of 600 students in a school, 150 students were found to be taking tea and 225 taking coffee. 100 were taking both tea and coffee. Find how many students were taking neither tea nor coffee. Let T and C be the sets of students who take tea and coffee. Then n of U is 600, n of T is 150, n of C is 225, n of T intersection C is 100, n of T complement intersection C complement what? Let us solve. N of T complement intersection C complement is equal to n of complement of T union C using De Morgan's law, which is again equal to n of U minus n of T union C, whose values are 600, whose is expanded in this, and put their values and simplify, we get 325. For question number 14, in a group of students, 100 students know Hindi, 50 know English, and 25 know both. Each of the students knows either Hindi or English. Find how many students are there in the group. Let S and E be the sets of the students who knows Hindi and English. Then n of I is 100, n of E is 50, n of I's intersection is 25, n of I's union E is what? Using n of I's union E is equal to this. Put their respective values, we get 125. Thus, there are 125 students in the group. Question number 15. In a survey of 60 people, it was found that 25 people read newspapers I's, 26 read newspaper T, 26 read newspaper I, 9 read both I's and I, 11 read both I's and T, 8 read both T and I, 3 read all the 3 newspapers. Find Roman number 1, the number of people who read at least one of the newspapers. Roman number 2, the number of people who read exactly one newspaper. Let us solve. We have n of u is 60, n of I is 25, n of t is 26. Similarly, n of i's intersection I is 9, n of i's intersection t is 11, n of t intersection I is 8, n of i's intersection I intersection t is 3. Using this formula, we get 52, which is the number of people who read at least one of the newspapers. For Roman number 2, n of i's only is n of i's intersection I complement intersection t complement, which is equal to i's intersection of I union t complement, which is again equal to n of i's minus n of i's intersection I minus n of i's intersection t plus n of i's intersection t intersection I. Note this formula. Put their respective values, we get I. Similarly, n of I only using above formula, we get this, and put their values and solve, we get 12. Next, n of t only using the red one, we get this, and putting their values solving, we get this. We have to find out, therefore, number of people who read exactly one newspaper is I plus 12 plus 10, whose value is 30. Question 16. In a survey, it was found that 21 people like product A, 26 like product B, and 29 like product C. If 14 people like products A and B, 12 people like product C and A, 14 people like products B and C, and I like all the 3 products, find how many like product C only. Here, n of A, n of B, n of C, n of A intersection B, n of C intersection A, n of B intersection C, n of A intersection B intersection R given. Therefore, n of C only using above formula, we get this, and put their values, solve, we get 11, which is the required value. Thank you for watching video.